So here's the second part of section 7.2, and we see another problem. We have a statistics instructor. They want to think about the mean amount of time that PCC students spend on social media per day. So 12 students are randomly selected, but we don't have the summary statistics, the mean and the standard deviation. We actually have all the data values. And these are how many minutes per day. So we want to make a confidence interval for this. We are told that we have normal distribution. So the 12 students is not such a big deal because we have that. And we're making a 95% confidence interval. Trying to figure out if we were to survey every single PCC student and ask them how much time they spend on social media per day, we want to be 95% confident that that true mean amount sits inside the confidence interval we create. So we're going to find our point estimate. So in this case, what you'll need to do is you will need to use the calculator. So the easiest thing, because you need mean and standard deviation for the error, is go stat and then just press enter, and now you're in your lists. And then choose a list and put your 12 values into your list. You can pause if you want to do that. Once you've done that, press stat, move over to calc, go to one variable stats, press enter, put whatever list it is that you put your values in, and then just calculate, and you're going to take your mean and standard deviation. So if you do this correctly, you should find that the mean amount of time for those 12 students is, and arguably you could do this on your own, but we need the standard deviation as well, so it's really easier just to use the calculator. But we get 95 minutes, and then I'll just put it up here, I'll use it in a minute, but the standard deviation, you should be getting 27.0689, and we'll use that. So we determine our critical value. Everything else is really the same. We'll do this by hand. So our alpha is 1 minus 0.95 for our confidence level. And arguably you could do as much of this as you're able to on your own. You can pause and see what you can do. We have 0 to 5. And we need our degrees of freedom. So 12 minus 1, we get 11. And we go into our table. And we notice that each of our tails in this distribution are 0.025, 0.025, and a 0.95 here in the middle. You can also think of it as 0.975 to the left of whatever our critical value is. So now let's look in our table. So one tail is 0.025. I'm not on the right table. 0.025 in one tail, 0.05 in two tails, and we just have a very low degree of freedom here. So I see 2.201. See if you see that as well. You can also do this by using inverse t and doing 0.97511. That will also give you 2.201. On the graphing calculator. Okay, we just need to put it together. Margin of error is our 2.201. Then that's times our standard deviation. Square root of 12, remember we are using n there. And we have 17.19887. A little bit weird there. Hopefully you can see that. Okay, so a little more than 17 minutes is our standard deviation. To construct the confidence interval, we take our 95 on either side, we subtract, we add the error. In the middle, we will have our mu, population mean, and 17.1989. I don't need too many decimal places on this. 1 decimal place is fine once I do the addition and subtraction. So over on our left side, 77.8. On the right side, 112.2. So 112.2. Then we just do as we always do and we interpret. So it's not enough to not have your sentence. Nobody will just randomly off the street be able to look at what you did there with the mu and understand it. So we want that interpretation. We are 95% confident that the true mean amount of time spent, so I'm just reiterating what it says in the instructions, like the directions for this problem, spent by all PCC students per day on social media is between 77.8 minutes and 112.2 minutes. Okay, so confidence intervals always point estimate, add and subtract your error, and then interpret. So the last thing I'm going to do for this section is think about something that we did in 7.1, and that's the idea of sample size. So the last example we did, we had an error that was about 17.2 minutes, give or take. We were 95% confident. We believed that the true, this is 7.2, so the mean number of minutes spent on social media was between 77.8 and 112.2. So just a reiteration of the last problem, nothing new. Now let's say we want to be 95% confident that this mean will be within 5 minutes. We'll be within 5 minutes of the true mean of all PCC students. One thing we'd need to do is increase the sample size since the confidence level is the same. So we need to find some sort of n. And we did this with proportions. Remember, it comes from the error formula. So you have your critical value there, your t-value, s divided by the square root of n. If we wanted to solve for n, we could do a couple different things. We will divide first by that t-value. Okay. Then we could multiply both sides by the square root of n. So I'm going to bring it up here just to have the space. Multiplying both sides by the square root of n puts it up here. But remember, we want to solve for n. That's the sample size. What sample size do we need? So now I'll multiply both sides by the t-value. Again, this is all just algebra. I'll divide by the error. Don't worry, this is not something you have to memorize. It's just to try to kind of understand the basics. And then if we wanted to find n, we would have to square both sides. So understand that that would be the last step. So that would give us here times the standard deviation over the error, and all of that would be squared. But that's a problem. And maybe you don't see the problem yet, but that's the problem. There is one. And that's because when we think about this value here, this t-value from the last few problems we've done, it needs degree of freedom. So it needs n. So how do you find a piece for a problem that is supposed to help you find n that needs n? That's the problem. So in a case like this, we actually can't do it. You're not able to find sample size with what we know and have for the possibility of finding some confidence interval. Like you want to find one, and so you need to take a sample and finding the sample size. Like we don't have that information because we need a t-value which requires n. So the only time we can do it is if we know something about the population standard deviation. So the only time we can determine sample size if we're talking about a mean is if we have population standard deviation. It's a weird thing to have. It would be very weird to want to estimate a population mean and somehow you have the population standard deviation, but it's the only time we can do it because otherwise, if all we have is a sample, it's just not possible. We don't have enough information. So we'll take a look at an example. Notice this is all about the president of PCC wanting to know how much time, a mean amount of time that students are spending at their jobs per week. And we want to know how many people she should sample to find a good 90% confident estimate. We have a standard deviation of the times, that's 2.5. We have the within words, so within 0.75. Anytime you see within, it should make you think error, because that's a very common word for error. We want to be within 0.75 hours of the true, population mean. And then the difference here is we want to be 90% confident, so we still have our alpha, but we're looking for a z-score, 0.10 divided by 2, so same there, but just with a z. So a couple things you could do here. If you notice that that's a very common confidence interval, you can, and a confidence level, you can look at your z tables and notice that the critical value is 1.645 from the tables. That's really the easiest way to do it. Otherwise, you could use inverse norm if you wanted to as well, or you could use the tables, but really if you use the tables, it's right in the tables. So now we just plug everything in, 1.645. We have that population standard deviation we were given and our error 0.75, and that is squared, all of it. So you'd want to do, if you can put that fraction in and then square the whole thing, that would be best. And you'd get about 30.0669. Remember, always round up no matter what. You can always, you never want to survey one less person than you need to, but you can always survey one more. Can't survey part of a person. So she should randomly survey 31 students. And that might not seem like a lot, but if you take a good random sample of students, this would be okay. But again, you'd have to know population standard deviation, which is not common. And that is section 7.2.